How to represent rational numbers on a number line? Well, let's understand this step by step. First, let's start with integers. Now, if you are wondering why we are starting with integers, then remember integers are rational numbers, right? So if we take this number line, okay, this is our number line, and if we mark integer 0 here, okay, now here we mark 1, this 2 at equal distance, 3, this 4, this 5, this 6, this 7, and so on. So this, on the right side to the 0, we are representing all the positive integers, right? All the positive integers come right to the 0, and all the negative integers will come left to the 0. So this becomes -1, this becomes -2, this becomes -3, -4, and -5. Now, we have discussed integers. 0 is an integer, 1, 2, 3, and so on are positive integers, and to the left of the 0 is are negative integers. Next number is of fractions. Now if you're wondering why fractions, so fractions, every fraction is a rational number. So in this case, let's take a fraction number 1/2. If this is our fractional number, now if you remember, we have learned this representation of fractional number when we are learning about fractions. In those tutorials, we have discussed all those things. But if you haven't watched those videos, don't worry, we are going to discuss it here. So this is 1/2. It means that in this case, since the denominator is 2, you imagine that since this is 1/2, so of course this is positive, right? All fractions are positive only, so it's going to come to the right to the 0. Now this 2 tells us that you think that all these gaps, that is between 0 to 1, then 1 to 2, then 2 to 3, then 3 to 4, and so on, are divided in 2 parts. Let me take with some different color. Let's take this color. So 1 part and 2 part, 1 part and 2 part, 1 part and 2 part, 1 part and 2 part. And why it is important will be clear to you. This is 0 and 1 is divided in 2 parts because this denominator tells that how many parts are there in one single unit. That is about the fraction, right? So this has been divided into 2 parts, and this one is actually what? This mark here is 1/2, because this one tells what? That you have to take 1 out of 2 parts. 2 means in how many parts a unit has been divided into. So we have divided this unit in 2 parts. You need 1 part, so you take this 1 part. So this comes as 1/2. Now if someone asks you that what will be then 2/2, then if you take it here, if this is 1/2, this one becomes 2/2, right? Why? Because this 1/2 tells us that the unit that you have divided into 2 parts take only 1 part, but in this case it tells that the complete unit you have divided into two parts. Now you want both the parts, so this part and this part, this part and this part, both. And anyways, if you want to check this, if you divide 2 with 2, you get what? You get 1 only. So this one is what? 2/2. So if someone asks you where you will represent 1/2, then you think that, okay, I divide this space gap between 0 and 1 into 2 parts, and this first mark will be our 1 over 2, and the next mark will be 2 over 2. Okay, so if this 1 is 2 over 2, now if someone asks you that where will 3 over 2 come on this number line, that's really very simple. If this mark is 1 over 2, this is 2 over 2, then this will be 3 over 2, right? And similarly, this 2 will be what? Will be 4 over 2. And you can check it. This 4 over 2 means what? 2 only. So if you divide this, you get 2 only. So 2 is 4 over 2. So in this way, we represent fraction. But let's go a little more deeper into fraction, because that's really very important. When we are discussing fraction, actually we are learning about rational numbers only, because fractions are rational numbers. Because that concept should be completely clear to us. Let's take, again, I'm just drawing it here so that we can magnify our representation, representation. So let's say that this 0 is here only, and we are not considering this negative integers because we don't need in case of fractions. So let's say this is 0, this is 1, this is 2, this is 3, and here it is 4. Now if I ask you that you have to represent 7 over 3 on this number line. Now clearly 7 over 3 is a fractional number. This denominator 3 tells you what? It tells you that the unit has been divided into 3 equal parts. A unit, or one thing, has been divided into 3 equal parts. Right? This is one part, this is first part, second part, and this is third part. Right? This denominator tells you. So this 7 over 3 tells you that, think that you have divided all these gaps, that is 0 to 1, 1 to 2, 2 to 3, 3 to 4, into 3 equal parts. So this is 1 part, 2 part, 3 part. 1 part, 2 part, 3 equal parts. 1 part, 2 part, 3 part. Right? 3 equal parts. Now, this 7 over 3, this is what? This is 1 over 3. This is what? This is 2 over 3. This is what? 1 is actually what? 3 over 3. Why? Because if you divide this comes as 1 only. And another way to think it, 3 over 3 is as that if you need 1 over 3 means that you are asking for this one part. If you need 2 over 3, it means that you are wanting this part and this part too. If you want 3 over 3, it means that you want all the 3 parts, that is this part, and this part. So clearly this will be 3 over 3, right? Similarly, this becomes 4 over 3, 5 over 3. This becomes what? 6 over 3. And if you want to check it, if you divide 6 by 3, you get what? 2. And this becomes, the one we want, becomes 7 over 3. Right? This becomes 7 over 3. So, our 7 over 3 comes at this point. Let's take some more examples. Let's say that you have to find what? Let's say you have to find 3 over 10. 3 over 10. Okay? I'm just quickly removing all these things so that we can discuss here. So we are ready with our discussion. I have removed, and that's why I had to pause this video. Now, this 3 over 10 tells us what? This 10 tells us that think that all these 1 unit, another 1 unit, another 1 unit have been divided into 10 equal parts. So let's quickly divide this. So if we have to divide it, this 1, then 2, then 3. Just forget this red marks that was for the previous one. 1, 2, 3, 4, 5, 6, 7, 8. So, and this 9, right? Similarly here, this 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, that will serve a purpose here. What we have to do, we have to find 3 over 10. So to the right, to the 0. Now this becomes what? This becomes 1 over 10. This becomes 2 over 10. This becomes 3 over 10. That's what we want, right? But let's go further and write all the remaining this marks here. This becomes 4 over 10. This was 5 over 10, 6 over 10, 7 over 10, 8 over 10, 9 over 10, and this one will be what? 10 over 10. If you divide 10 by 10, you get what? 1. Imagine if it was asked what will be 15 over 10. Then can you tell? Yes, of course. 10 tells us what? That divide all these units into 10 equal parts. Then this one is what? 10 over 10. So this is 11 over 10. This mark is 12 over 10. This is 13 over 10. This is 14 over 10. And this is our 15 over 10. Can you tell 23 over 10? Yes, we can tell. This 2 is what? This 2 is actually 20 over 10. So the next 3 marks, that is 1, 2 and this 3. So this is 21 over 10, 22 over 10, and this becomes what? 23 over 10. So this is about fractions. First we discuss about integers. Every integer is a fractional number. Then we discuss about fractions. Every fraction is a rational number. So the remaining thing is what? Of the negative integers. Let me tell you one thing. Whatever you have learned for this positive integers or the positive fraction numbers, right? Whenever you have discussed for whatever we have discussed till now for this fractional numbers, you have to do exactly the same thing towards the the left of this 0. Just forget for a moment about this minus sign. Just forget it and just go on doing whatever we have done it here. Now if you're wondering what do we mean by that, so let me do that. Let's take a fresh number line. So here it is, a fresh number line, and now I'm going to deal with the rational numbers having negative numerator or denominator. Okay, so let's suppose that our 0 comes here. We are not focusing on the positive side, right? Now we are focusing to the left, that is the negative side. So if this is 0, let's say that this is minus 1, this is minus 2, this is minus 2, this is minus 3, and let's say here comes minus 4. Now let's take the first example here. This is 1 over 2, so I'm going to take minus 1 over 2. Okay, this 2 tells us what? The denominator tells that imagine that all these units have been divided into 2 equal parts. So 1 part, 2 part, 1 part, 2 part, 1 part, 2 part, 1 part, 2 part. Now you have to tell what? You have to tell minus 1 over 2. Just forget about this minus sign and just do it. How will you do this? So this one becomes, this one is what? 1 over 2, right? Just put minus sign here. So this becomes minus 1 over 2. This is minus 1. So clearly this minus 1 is what? This minus 1 is minus 2 over 2, right? Same thing what we have discussed here. This becomes what? This is actually a minus 3 over 2, right? So if someone asks you that how will you represent minus 3 over 2 here? That's here. Now suppose someone asks you that this is minus 1 over 2. What if this is 1 over minus 2? Because we know that in a rational number you can have negative integer in denominator also. Not only in the numerator, but even the denominator can be a negative integer. Then what? Remember what we have discussed in our earlier videos, that if your rational number is of the form p over minus q, then this can be written as minus p over q. Just go to our previous videos. Let's go into the playlist and watch those videos, right? So this is written as minus sign in the middle, then p over q. So on the basis of this 1 over minus 2 is nothing else but minus 1 over 2 only from this one. Okay, from this one we can write minus 1 over 2. Similarly, if someone asks you that how will you represent 3 over minus 2? So 3 over minus 2 means what? From this we can say that it's nothing else but minus 3 over 2 only. Okay, so let's take another example. In this case, what was our next example? Our next example was 7 over 3. So this time I'm going to take minus 7 over 3 or 7 over minus 3. Both these two are equal, so same thing. Let me quickly remove this. Okay, so here we are. This time this is minus 2 and this is minus 1. This time it's asking minus 7 over 3. Forget about the negative sign. Think of 7 over 3. So divide this into 3 equal parts. 1 part, 2 part, 3 parts. 1 part, 2 part, 3 part. Just ignore this, the previous one. 1 part, 2 part, 3 part, right? One part, 2 part and 3 part. Though it's not looking equal, but just assume that these all are equal parts. So now this is what? This is minus 1 over 3. This is minus 2 over 3. And this is what? Minus 3 over 3. This is what? Minus 4 over 3. This is what? Minus 5 over 3. This was 2, so this is what? Minus 6 over 3. And this becomes what? Minus 7 over 3. Right? So, what was next one? That was 3 over 10 and 15 over 10. Can you do that? I'm just leaving that portion for you. That is minus 3 over 10. Or someone asks you for 3 over minus 10. Or someone asks you about minus 15 over 10. Or 15 over minus 10. I'm leaving these two for you. That's really very simple, right? We know how to do that. The main thing is this: first focus on the denominator, then divide each unit into that many equal parts. Like if this was 10, we divided this into 10 equal parts: 1 part, 2 part, 3 part, 4 part. The same thing you will do on the left side, because here you have negative sign. So this is all about representing rational numbers on a number line.